A massive warehouse fire in Melbourne, Australia sent a towering plume of smoke into the sky as thousands of lithium-ion batteries burned. Firefighters battled the intense flames, but was this disaster preventable? A warehouse in Cheltenham, a suburb of Melbourne, caught fire as thousands of lithium-ion batteries burned, sending explosions echoing through the area. Reports indicate the facility stored around 3,000 lithium-ion batteries. They were lithium iron phosphate, LFP. This company specialized in lithium-ion batteries that looked like car batteries. They were 12-volt, ranging from 100 to 4,000 watt-hours per unit. To put that in perspective, think of watt-hours like gallons of water in a bathtub. The higher the number, the more energy stored. Reports state that the 000 caller, Australia's version of 911, reported the fire started in a stack of batteries. There's a common misconception out there that lithium iron phosphate batteries can't burn or go into thermal runaway. While it's true that this chemistry is more stable and harder to push into thermal runaway, it's not immune. And when it does fail, it does have serious drawbacks. LFP batteries, they release 50% hydrogen during the off-gassing phase, compared to about 20% in many of the other lithium-ion battery chemistries. That means there's a much higher concentration of that flammable gas, and that increases the risk of explosion. Fire crews rushed to the scene, but it was a losing battle from the start. Flames had already torn through the roof, and it took firefighters about 6 hours to bring this fire under control. On top of that, they faced another challenge: aging equipment. With 35 fire trucks on scene, 2 suffered pump failures, further complicating efforts to contain this blaze. What we don't know right now is how these batteries were stored. Did the building have fire suppression? Did it have a fire alarm? In this case, a fire alarm likely wouldn't have made much of a difference, as it sounds like the witness actually saw the fire firsthand. But fire suppression, that's crucial. A facility storing this many batteries should have had ceiling-mounted fire sprinklers, as well as in-rack fire suppression for any batteries stored on racks. And while the sprinkler system wouldn't extinguish a battery fire, it should slow down the spread and help protect the structure. That would allow firefighters to get in there and stop the fire. Storage spacing is also critical. Lithium-ion batteries should not be stacked in endless piles without separation. Isolation and ventilation play a huge role in preventing a small fire from turning into a disaster. Speaking of ventilation, did they have any? Did the warehouse have deflagration panels? As I mentioned earlier, LFP batteries off-gas a significant amount of hydrogen, a highly flammable gas. Without proper ventilation, that gas buildup becomes an explosion waiting to happen. Another big question: was this warehouse storing batteries safely and legally? Was the facility properly inspected by the fire department? Did local authorities know they were storing batteries? If this facility lacked proper safety measures, this could be another case of batteries being stored without a proper risk assessment. So what are the risks to the community? Any fire this magnitude, batteries or not, pose a hazard. But in this case, you've got a lot of other nasty chemicals coming out of that structure. I've seen a lot of concern over hydrogen fluoride gas, which, when mixed with water, turns into hydrofluoric acid. And yes, that sounds bad, but in reality, the gas is extremely reactive. In a fire like this, with the extreme heat and a mix of all the other products of combustion, it's going to break down and react quickly before it has a chance to become a major issue. And if it does become hydrofluoric acid, it's going to be massively diluted by the millions of gallons of water that the fire department is pouring into that building. What's more concerning is something that we're just starting to get data on: heavy metals in the smoke. In fires like this, you could see aluminum and copper, and depending on the battery chemistry, nickels, manganese, and cobalt. These metals don't just disappear. They can settle onto surfaces in the surrounding area and potentially contaminate water and soil. But it's an area that we still don't have a lot of data on. And speaking of water, runoff is another big unknown. We still don't fully understand what's in the runoff for fires like this, especially when lithium-ion batteries are involved. But considering the sheer volume of water used, it's something local officials should be investigating. This fire isn't about one warehouse. Across the world, lithium-ion battery storage facilities are becoming more common, especially as businesses stockpile batteries for energy storage, EV charging, and recycling. If safety regulations don't keep up, we're going to see more of these large-scale incidents. Fire departments need to be prepared, businesses need to store batteries responsibly, and regulators need to address the growing risk of large-scale battery storage. Because if we don't, it's only a matter of time before the next warehouse goes up in flames.